Hello, number 8. Welcome back. All right, so we're in number 8, page 774 of chapter 11, section 11 of Stewart's Calculus with Early Transcendentals, 7th edition. And f of x is given as x times cosine of x. And we want to get a third-degree Taylor polynomial estimate or expansion near a equals 0, so it's Maclaurin. It's a special case of Taylor. So it's in powers of x, not powers of x minus a, or x minus 0, I guess. So we're going to need three derivatives. So how about f prime and f double prime? There's a lot of product rule stuff here, so I'm just doing this straight in the computer algebra system because it's a pain. You could do it by hand, but it's going to take all day. Alrighty, so what would that be? Well, that would be the differentiate, right, of f of x with respect to x. But then what's f double prime? It's the derivative of f prime with respect to x. So let's tell it to differentiate f prime. And what's f triple prime? Well, it's a derivative of f double prime. So we'll copy that, put it here, and make it f double prime. And now let's show all this stuff. See what we got. We're evaluating this at x equals 0, so our center of convergence or interval convergence will be at x equals 0. So remember, a Maclaurin series is good at 0 only, or near 0, or everywhere, like e to the x, sine x has got an infinite radius of convergence. All right, so here we go, as opposed to a Taylor polynomial, which is only good at a, or near a, or everywhere. And here we're going to do the same thing here. Make it f prime, f double prime, and f triple prime. I'm sure you could do this by hand. There's a ton of product rules and whatnot. And ignore the output until I hit evaluate. All right, so there's f0, no derivatives, the function, f prime, f double prime, f triple prime, which I'm sure you could confirm on your own. First times the derivative of the second, which is negative sign, there it is, plus the second times the derivative of the first, which is 1, yep, there it is. Then differentiate again, and another product rule here, and a product rule, okay, so there you go. Now I want to evaluate this at 0, so let's just replace all the x's with zeros. We can figure out our expansion using Taylor theorem, or Maclaurin's, actually. Let's see what the values are. So f of 0 is 0, so that drops out. F prime is 1, f double prime drops out, f triple prime is negative 3. So what is your third degree Taylor polynomial p sub 3 of x? It's going to be 0 plus 0, yeah, plus, well, technically, all right, let's be complete, times x to the 0 over 0 factorial, which is 1, okay? Then plus f prime, which is 1, times x minus a, which is x, to the first over 1 factorial, which is 1. Right. Well, let's write it down. 1 factorial is 1, 0 factorial is 1, okay. Plus f double prime, which is 0, times x minus a, which is x, to the second over 2 factorial, which is 2. And then, so those zeros are just dropping out. I'm just writing out the theorem so you know what I'm doing. And plus quantity negative 3 times x minus a, which is x, to the third over 3 factorial, which is 6. And let's show that. P3. And so it's x minus x cubed over 2, if you want to read it backwards. All right, see what the graph looks like. So let's plot. List f of x and p sub 3 of x. P sub 3, what did I just said? P sub 3 of x. Now the center of convergence is 0, so let's graph this. So say from -1 to 1. So we can see the center in the middle of the screen, -1 or in the middle of the graph. to 1. And again, the magenta curve is F, and the cyan curve is F, and the green curve is our estimate. And it's exact at 0, and it's pretty good near 0. So there you go. There's a third-degree Taylor polynomial expansion for that function, which was, what was it, x times cosine x. So the blue curve is x times cosine x, and the green curve is our P3. So there's your output. There's your input. There's your work. Well, no, we didn't do any work there. We just did it all here. And I hope that was helpful. Bye-bye, numerates. See you next time. Good luck with your homework.